How are you doing today? Today we are in chapter 3 of volume 1 of the operation of wastewater treatment plant from the Sacramento State. When we talk about preliminary treatment on page 136, we were talking about the process in which we remove coarse materials such as cans, bottles, pieces of scrap metal, rocks, bricks, plastic toys, lids, caps, hypodermic needles, um, any of that stuff that people flush down the sewer. In my over 15 years, it's somewhere between 15 and 20 years, I've seen a lot of toys flushed down the sewer. I've seen marijuana leaves and I've retrieved bricks. So anything that you can think of, unfortunately, gets flushed down. And especially when we talk about the combined sewers, where stormwater has infiltration, in the larger municipalities, it is really hard to tell what you can find. And so you can find animals, um, just a wide variety of things, especially now with the flushable wipes. We see a lot of people flushing those down. And I know in previous talks, I've explained that just because it's flushable doesn't mean that it's pumpable. On the bottom of 136, we have flow measurement. It's important, and sometimes I'm not 100% sure, but maybe your regulatory agency requires that you record influent flows. We want to record the influent, what comes into the plant. We want to record it not only for our own personal records, but also because we want to be able to control our downstream processes. So if you know you have a lot of water coming in, you can change maybe your aeration tank setup or your return pumps. You can really kind of plan when you have know what kind of flow that you're coming in. Screening. We've talked about this. Screening, this is the part of the preliminary treatment that removes large debris, rocks, cans, bottles, rags, grit removal. We want to remove any of the rocks, sand, eggshells, coffee grounds, as maybe your collection system is deteriorating, chunks of concrete, little chunks of concrete. We want to remove that from the system. That grit can cause wear on your impeller and also the wear rings between the impeller and the volute. And so not only does it take up valuable space in the aeration tank or the secondary treatment, but it also can cause wear on your pumps. Pre-aeration. A lot of plants pre-aerate, meaning that they add air to their influent as it comes in. A lot of times we'll do that for grit removal, but it also freshens up the the wastewater coming in. Emergency storage. If you Google bigger cities like Chicago, Phoenix, those types of things, they have large storage areas because they're combined sewers, perhaps. And the goal is to, during a rainfall event or a surge, that they can store that in either pipes underneath the ground or a reservoir of some sort. And then on drier days, they can bring that wastewater back through the plant to be treated. Turn over to 139. In the preliminary treatment area, there's a lot of particulate atmospheric hazards. One thing that we need to be aware of is the hydrogen sulfide, the methane, which can explode, uh, can cause explosive mixtures in the air. So anytime we go into a valve pit, either out in the collection system or our influent building, we want to be very cognitive of the air quality coming in. So maybe you need exhaust fans, maybe you need to monitor that air, especially before you come into a confined space. We want to monitor that air. As the influent comes in, we need to, the bottom of page 139, we need to know that there is a greater chance for diseases. So dysentery, hepatitis, cryptosporidium. Uh, we need to take proper protection, wear our eyeglasses, wear respirator. I know in our particular facility, when I'm dealing with the grease removal, and sometimes I have to push the grease to the auger, I would like to wear a respirator because it gives off those gases and that bacteria actually gets into your nostrils and can make you sick. So we want to practice good hygiene around our influent. On page 143, these are the different flow measuring devices. Under head area, you have your weirs and your flumes. And I want to particularly point out the partial flume, which is what a lot of plants use. These are for partially filled channels or basins. Our velocity meters are those meters that are enclosed in our pipe. So those are propeller. Propeller is the ones that actually, as the wastewater moves through, it spins a propeller. And then your magnetic meter. So it has no internal working parts, but it takes the magnetic forces and creates a corresponding flow measurement. The importance of that is we don't, a lot of times with a mag meter, we don't have those internal parts where something can get clogged. And so those are kind of ideal sometimes in the application we have. Shunt flow, those are for gases. We have the differential producers and the displacement units. Over on page 144, you have a basic rotometer that is used for gases. The flow comes in, the float raises up, and then you have the outflow. Partial flume down at the bottom, as you can tell, it has a converging and then a diverging section, and there's a mathematical calculation to get the flow then. Rectangular weir on page 145. On 146, location of measuring devices. We want to put our flow meters at least 5 pipe diameters away from any bend, elbow, or valve. I was putting in a pH monitoring system, and we want that to be centralized in 5 pipe diameters away, because any elbow or valve that we have in the system will create a disruption in the flow and will give an inaccurate um, reading. Bottom of page 147, transmitters. They send a flow variable as measured by the measuring device to another device for conversion to a usable number. We have our receivers down at the bottom on page 148. You can see a uh, chart recorder. When I first started, these were uh, the mainstay in the water and wastewater industry. I don't know. I think some of the older plants still have those. Maybe your regulatory agency requires that. But a lot of what we're going to now is the computer-based systems, the SCADA systems, where it tracks that corresponding flow or number in the SCADA system. And then every day, usually you write down the flows. When I first started, we would walk to each meter and write down on a piece of paper every flow in the plant and then take it back, put it on the master sheet. With technology, the radio reads, the hardwiring, a lot of times we don't have to do that. We still have to write the flows down, but it comes into our SCADA system, our computer system that operates and controls the wastewater plant. We have lots of sensors that are out. Um, our SCADA system will do conversions and read out. They'll take that information from the instruments and do the conversions for ourselves. It is important as an operator to know what conversions we need, but the the SCADA system has come a long way with that. Every meter should be, unless otherwise told by your regulatory agency, should be checked annually. We want to, as operators, be as honest as we can, and the EPA wants correct data. To do that, we need most likely someone from the outside agency to come in, check your meters once a year, verify the accuracy and precision of those meters. Screening and shredding. On page 154, you'll see bar racks and bar screens. So racks are a little bit bigger when we talk about racks. They are manually cleaned to their infrequent use. Bar screens are a little bit smaller. They're 3/8 to 2 inches. And every smaller plant would probably have like a rack screen or a bar screen, I'm sorry. And this can be used to manually clean. A lot of them do not have automatic equipment to clean those. But the bigger plants, they don't want to pay someone there to just clean the screen every 30 seconds. And so we have automated equipment that clean those screens. The screen at my facility is a circular, and as it goes through the wastewater, flows into the middle and comes out the side. And as the screen picks up material, there are jet nozzles that then wash that down into an auger and then disposes into a dumpster. We want to keep that clean. As operators, usually the influent building is one of the most neglected. We want to keep that area clean for our safety and just to be professional. A lot of times when we take tours in there, it kind of cuts down on the gross factor. On page 157, mechanical cleaning equipment. It should be lubricated and well adjusted. We want to make sure that it is clean and maintenance well. On page 158, you'll see a mechanically clean bar screen. And as the influent comes through, it picks up the material and disposes of that into an auger. When we talk about on page 161, we talk about solid grinders, also called commutators. For your test, you'll need to know the difference. But they are devices that intercept coarse solids and grind or shred them in a channel or pipe. The On the bottom page, the routine operation of grinders and commutators is basically the same as the operation of screens and rack. The main factor are the number of units, the amount of debris in the wastewater, and the head loss through the unit. Grinders and commutators, as the flow comes in, grinds, shreds everything. Me personally, I'm not a big fan of this, is because I want to remove that rag or that wipe or that tampon. I want to remove it whole when it first comes in. Now, certain applications, you do need a grinder or commutator, but if I can get rid of it and not shred it, because as the material says, it has a chance to come back together later on in the treatment process. And I really don't want a coarse mat of stuff to come back together in my aeration tank or my clarifier or in one of my RAS pumps. They have their uses, sure, but if all possible, in my personal opinion, I like to take the rags out as a whole. You have some pictures on 162 of N-channel solid grinders and commutators. You can see them in the channel actually working. Grit removal, bottom of page 165. This is the simplest means of removing grit from the wastewater is to pass the flow through channels or tanks to reduce the water velocity to a range of about 0.7 to 1.4 feet. You have grit coming in through maybe a 36-inch sewer. At my facility, we open that up into a channel. As it opens from 36 to, let's say, maybe a 7-foot channel that is 20 feet deep, it slows down the water and the grit will settle down to the bottom. And that's the goal in grit removal. As I mentioned in earlier videos, we have it about 2 feet per second in our sanitary sewers. So we want to bring that level down to about 0.7 to 1.4 feet. On page 166, there is a grit settling area that you can see. On 170, grit chambers can have dead spots where organic material settles out and becomes protrusible. We want to make sure in our grit removal that we do not have any dead spots. The reason why we don't want any dead spots is because we don't want odor in our influent building. And so we want to make sure that we are proper aerating that and we're not attracting flies and rats. On the page of 172, you see flights. As that grit falls to the bottom, those flights will pick up the grit and move it to a central location. On 173, you'll see the water surface. As grit and water comes through, we add air. It creates a vortex motion. I don't know, when I was a kid, we used to ride the Gravitron. I'm sure you're familiar with it. It would spin us around, and the force would fling you back to the back of the uh, amusement ride. Same principle. We're trying to use a vortex more motion to get rid of the grit. The aeration, and we'll go on it, but the aeration actually removes the organic material from the grit because we want the grit to have very little organic material, once again, for the odor and the smell. 175, you can see a picture of a cyclone grit separator. Obviously, the wastewater comes in, the grit goes to the grit hopper, goes to a grit pump, and once again, we use the cone method. It's a machine, and that vortex is what we're looking for to remove our grit. And then obviously it goes into a storage bin or disposable truck. On page 176, we can kind of see some more cyclone grit separators. That grit usually, depending on your regulation, can just be disposed in a dumpster, and your local waste hauler can come and take that to the landfill to dispose of. On page 178, you can see a grit washer. Once again, we are trying to remove the organics that are coming into the wastewater plant. And 180, disposal of grit. Regardless of the method, at least 6 inches of soil should be placed over the grit to keep out rats and to prevent odors. That's on final disposal. Disposal. Emergency storage basins. Once again, your facility, I worked out more towards the central states, and we had 2 lagoons that were decommissioned in terms of wastewater treatment, but we would use those as storage. So when it would rain, I would send the flow out to the lagoons, and then on drier days, I'd bring the flow back in to be able to treat it. A lot of your package plants will actually have a EQ basin, and that stands for equalization basin. It just buffers those flows that come in on those high rain events. Well, that is the end of chapter 3 on preliminary treatment. I hope you have a great day. Thank you.